We have Earl Joseph, the CEO of HPC industry analyst firm Hyperion Research.
How can you take all these AI ideas around the world and actually use it for science and engineering?
Right. So I think we've gone from big data to good data.
From Orion X in association with Inside HPC. This is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey everyone, and great to be with you again, Shaheen.
Great to be with you, Doug. We have a special guest.
Yes, indeed we do. We have Earl Joseph, the CEO of HPC industry analyst firm Hyperion Research. Earl, this week the firm put out new market findings, updated market numbers. Earl, glad to be with you.
Hey, thank you very much for having me. I appreciate it. Yes, we just announced that last year, 2021, turned out to be a very high growth year for HPC. With COVID, the supply chain issues, and everything else, we were expecting 2021 to be moderate growth year, but instead right now we're looking at 3 actual quarters and our forecast for fourth quarter, and at a minimal it's going to be growing in the order of 12, 13, 14%, and so we're just amazed at the amount of growth rate. If fourth quarter comes in strong, the growth rate will actually be higher than we announced right now. So we're very excited about the tremendous growth right now. If you look at the servers, the storage, the other aspects of HPC is for on-premises servers, it's exceeded $27 billion last year.
Wow.
So just tremendous growth rate.
Earl, a couple of years ago, since COVID started, that had a disproportionate impact on everything. Are we out of that? Are you still seeing impact of that?
Well, the previous year, the first year of COVID, we were expecting the market to decline 7 to 8%, and the broader market as a whole actually did decline by that amount, close to 8%. But there was one sale in Japan at Riken that was $1 billion. And because that $1 billion sale hit, that year it actually grew by 1%. But what we saw, because of supply chain issues and also the whole purchase process, whether it's, creating a purchase order, doing the evaluation and that, people weren't allowed in buildings. Everything got delayed out dramatically. We are still concerned that fourth quarter may still have the supply chain issues for last quarter, which is what we're referring to as fourth quarter. So it's better, but it's not out of the way yet.
So one question is, what is driving all of this? And to what extent is it AI masquerading as HPC? Or unless you, like me, think AI is HPC, then we're all good. Can you speak to that?
Right. So, our definition of HPC includes any kind of server that's used by scientists, engineers, analysts, and others to do highly computational or highly data-intensive work. So it's really driven by what they're using the computer for. It could be any kind of hardware or software, but it's the end application. And so the basic HPC modeling and simulation is growing tremendously because around the world, companies, universities, and governments recognize that innovation and R&D is key to competitive growth, especially when you're in really difficult economic times. So we're seeing sizable investments there. But then the AI with its machine learning, deep learning, it's giving just tremendous new opportunities. And so we're seeing AI purchases just across the entire market. Now, in some cases, it's still experimental in the sense that people are trying to figure out where it fits, what's the right way to do it, what kind of software, how can I get enough data to really do it? But we're just on the cusp right now of AI, machine learning, deep learning growing dramatically. Now, we also include quantum computing in HPC, and there's a tremendous amount of investment in quantum computing. The purchases as far as the quantum computers and cycles isn't quite as much, but the investments there is tremendous. But we're also seeing all kinds of new emerging technologies. So new types of AI processors, new types of memory. So it's just a really robust time in the industry.
Well, we had Bob Sorensen, of course, your colleague, last month talking about the quantum market. And we were very surprised, actually. I think both Shaheen and I were, that it's a $500 million market now. And a lot of that being POC kind of work, but very interesting. The one question I had, Earl, could you get into, we know that cloud-based HPC has been a hot growth sector. Could you split out cloud HPC versus on-prem and in terms of growth rates?
Sure. So the announcement we just made on Monday, that was only on the on-premise side of the business. So what we track on on-prem is the actual purchase of hardware, software, services, to install a computer and run it. On the cloud side, what we track is how much people spend in the cloud. We don't track the actual items in the cloud from a hardware, but how much people spend to do HPC work. A couple of years ago, we declared 1999 as a tipping point because the expenditures were $1 billion more than we were expecting. And we may declare either 2021 or 2022 as another tipping point. The growth in cloud is growing dramatically in the order of 17 to 20% a year. whereas the on-premise side of the business is growing around 8% a year. So just tremendous growth there. But one of the tipping points that we found happened middle of last year is that for the first time, we saw people moving on-premises budget to the cloud. Prior to that, the cloud expenditure was new money, or new budget money and everything else. And again, there were a few exceptions to that. But last year, we saw a number of sites that said, well, we're going to take a little bit of our money and from what we would have purchased on premise and spend in the cloud, or we're going to wait an extra few months or a couple quarters before doing an upgrade and spend that money. That was the first we saw, a sizable amount of that activity.
Is there a correlation between that and the size of jobs, or whether it's just search capacity, or is it just fundamentally kicking the tires and seeing how it works on the cloud?
Sure. That's also the phase we feel the world went through last year. Because prior to last year, the bulk of it was that experimental or kicking the tires, trying some small jobs, figuring out where it all fits. People always understood the embarrassingly parallel problems fit well in the cloud. The bio life sciences, drug discovery, genomic stuff was strong. But really about the middle of last year, a lot of sites really figured it out where it made sense and what type of jobs run well in the cloud and which don't. So first of all, you have to make sure that, the cloud is secure enough and various other issues, but then it's the right software, the right configuration. And quite frankly, the cloud providers have done a tremendous job of making their clouds more HPC friendly, having the right setup, the right type of hardware. I mean, you can even go in the cloud and run your stuff on a Cray right now. So part of it was the CSPs did such a better job over the last few years of making their offerings more easy to use for an HPC user.
Yeah, actually, to your point, the number of configurations that are available on cloud have just mushroomed over the years. I was asking somebody whether they knew just how many different instances exist on one of the clouds, and the number was like approaching 500 over the years, right?
Oh, it's just amazing. Yes, absolutely amazing.
Earl, what's an inhibitor to growth in cloud HPC? Is it data location, or what holds people back, or why do they stick with on-prem?
Oh, great question. So we are trying to track, we try to track all the applications run on HPC systems, and we're creating this model of the ones that are, I'll call cloud friendly, ones that are cloud not so friendly or make more sense to stay on-prem for a long time, and then all the ones in between. And we actually have 13 different types of questions we asked various end users of applications. The data locality is still very high on the list in data security. So if your data is already in the cloud, it makes a lot of sense to do your processing up in the cloud. If you have massive data sets that are on premise, it's costly to move it around. So the movement of data is very expensive. The other part that we find is the nature of your application. If your application is a traditional hard HPC job, where parts of it are moving around, thousands of processors and tens of thousands of nodes perhaps. When you put those up in the cloud, the cost of running those can get very high, especially when you start having different geographies where your job is being split over. So if you split your job across multiple geographies, bandwidth and latency become major issues. But what we found in the last year, we think that a lot of stuff moved from the experimental to actual production mode, where people figured out what made sense, what doesn't make sense, and working through that. There's also still a lot of paranoia around security. So I always have to mention, security is a big issue. And then our view is the major driver to really shift the dial is the ease of use. How easy is it to get your job up in the cloud and performing well? And for HPC, everything has to perform well before you're going to do it. But that ease of use factor, and even companies like Rescale, what they're doing has helped tremendously there. But that ease of use function is very important.
Earl, is there such a thing as a private cloud anymore? Or is it all really public when we say cloud?
Right. So we're actually going to be adjusting our definition some. Right now, if it's a private cloud used within one organization, we call that on premises. And just because if you look at cloud software and how cloud's being implemented, a lot of sites have turned their stuff into a cloud, but only for their organization. And so we go more by where it's located, who
Location,
owns
right?
it, and who uses it. Thanks for this question, because when I use the term public cloud, I'm referring to really an external resource that somebody else has used that's shared by multiple users.
I appreciate that because I've asked several times. Many people have explained to me the difference between an on-prem data center and a private cloud, but I can never keep it in my head. So I'm glad you you made that distinction. By the way, Earl, you in the announcement you used the term mainstream markets. Could you give us a quick definition of what that means? Does that mean traditional HPC or What does that mean exactly?
Sure. In our view, what's going on in the market right now, you have a very high-end leadership exascale class buyer and a set of systems, and they're going on a different trajectory in a different direction than all the rest of the buyers. So when we say mainstream, we're really talking about the bulk of the market that's, on a different path than what the really extreme high-end portion is. And so the mainstream is just means most of the buyers out there.
And also, are you seeing anything interesting on the processor end? Today, we had the news broke that it could well be that NVIDIA is finally giving up the ghost on the ARM deal. Yet, as we all know, the world's most powerful supercomputer is an ARM based as well as a GPU based system. Is there anything interesting on the processor end that you're seeing?
Yeah, the processor side of the market right now is the most fascinating for us. Alex Norton on our team is tracking, I think, over 100 different custom processors, FPGAs, and that just in the AI, machine learning, deep learning, big data space. But the interesting thing we're finding too is Europe wants to build their own processors. So SiPearl, the EPI, and the Europeans are developing processors. And then you have China that's developing, historically they had 7 processor lines for servers. There's about 3 of them that are likely to be sizable. And then the cloud providers are developing their own processors, whether it's GPUs at Google and so on. And Alibaba announced that they're developing their own processors. So the whole processor selection of choice is just expanding tremendously right now. It's a very fascinating part of the market. It is a big problem for the vendors though, because if you're a large vendor and you want to sell in all the geographies around the world and all the sectors, instead of designing, an x86 based machine with an NVIDIA GPU, you now have to design a machine that may have 8 or 9 different types of processors and 3 or 4 or 10 different types of accelerators. So the system design part's much more complex for the vendors.
Yeah, I think that's been fueling more of a customization for systems because people want to try all these different options.
Very much so, yes.
Now, what about verticals, Earl? Who's driving there? Obviously, drug design was in vogue and in public eye. Energy has always been important, et cetera, et cetera.
Right. So, in the very high end, it's the government labs with exascale is one part that's, just driving the market like crazy. Manufacturing, though, is kind of the bread and butter market, whether it's cars, planes, dishwashers, cell phones, TVs, and everything else. That's where a lot of the competitive value of HPC is, especially when you start putting AI into it. And then we're seeing the new ones, the smart cars, smart cities, where you actually can redefine how we interact with the world, whether you're actually driving the car or not. We're also seeing some very interesting, unusual or different, like in the defense area. There's some folks that feel that in the near future, most battles are going to be fought with computers, just like in all the science fiction stuff. And the concept is there's already cameras, sensors of every form in every vehicle, and they're on every soldier. You could actually have the computer telling the soldier what direction to point their rifle, literally in real time, faster than any human could think through and control the whole scene. So in that case, just like in science fiction, who's got the better computer wins.
Now, that sort of leads to the data part of it because all this data coming from all these sensors, some of it rich data, a lot of it unstructured, they all have to flow somewhere. Are you seeing that the data part of the equation versus the computational part of the equation, or the algorithms and the models part of the equation, getting more attention or being viewed as critical?
Yes. For regular modeling simulation, the data is crucial, like you said. But when you get to machine learning, deep learning, its importance just skyrockets again. And you have a whole lot of issues, like, is your data really that clean and accurate? Are there biases in your data that you're going to end up with the wrong answer? And so the whole aspect of data, having enough of data, first of all, for machine learning, deep learning is a big deal. The importance of data has just skyrocketed in all these examples. And like you said, how do you integrate different types of data, different form factors? We're doing some work for the Department of Energy for Rick Stevens as far as trying to figure out how can you take all these AI ideas around the world and actually use it for science and engineering.
Right,
And
exactly.
it's just fascinating because it's opening up whole new venues. And the other part I have to mention related to what you asked is how do you deal with the edge? Because the edge is kind of what's generating all that data. And the variety of edge devices, even if it's all video or if it's all zeros and ones, it's coming in such different form factors from everywhere. And if you want to do it in real time to actually respond to something, you need a substantial system.
I really think so. I think we've gone from big data to good data.
I like that. That's
Better
perfect.
data,
That's
higher
perfect.
quality data. That's good. All right. Any surprises, Earl, in your findings?
Yes, so the biggest prize for us for last year in our announcement is that it was across the whole market. Often we'll see these spikes in the market or high growth rates, show up because one or two giant systems were sold, but it was really across the market. And also when we collect our data, we base most of it on surveys in, just thousands and thousands of buyers, but also the vendor side. And every quarter for the last 5 quarters, the vendors have really been worried about the supply chain, but they seem to be able to stay on top of it enough. So kudos to the vendors for dealing with, all the supply chain issues. So that was a big surprise. The other one is the kind of whisper, then stuff about the Chinese exascale machines. They chose not to go public, submit to the top 500, but they actually installed a couple of sizable systems last year. In the first 3 quarters, we have one of them because we believe one was accepted about mid-year, and we think the second one will be accepted in the 4th quarter.
So the state of the industry is quite healthy, according to this window.
Far healthier than we would ever imagine, given COVID, all the other issues in that. Again, I think it's like the last 2 economic downturns where some nations, some companies decided that the real way to get out of these problems is to invest in being innovative, invest in R&D, and try to do better than everyone else. And HPC is the big tool behind that.
Well, speaking of China, how many different countries do you actually track and have on your radar?
Right. So our data structures and everything go down to 28 different countries. And so we track them on a quarterly basis, what's going on. And that's by, a dozen verticals. And it also includes the servers, the software, applications, services in that. So, it's quite extensive tracking. And the data structures, go back decades. And we always have to have 5-year forecasts on everything.
Right on. Well done. Thank you. This is excellent.
All right. Well, thanks so much for joining us today, Earl. It was a real pleasure.
Oh, thank you very much for inviting me. I appreciate it.
Take care.
All right. Bye-bye.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.